can go bad fast. They can go from bad to worse even faster. Destroyed in Seconds, a new series full of stuff that didn't end well. This week. See what happens when it all goes wrong. Destroyed in Seconds. New episode tomorrow at 9. It's all new on Discovery.
Welcome back to another case study of things you should never try at home.
Okay.
Need a reminder?
3, 2, 1.
We just showed what can happen when oil, water, and fire mix.
Whoa. Oh, my God. Well, that was amazing. I mean, 1 cup of water, and we have a 20-foot plume of flame.
But there are other ways that ordinary household items can explode. And by ordinary, we mean ordinary.
If you've ever seen a Halloween punch bowl before, you're looking at the delightful mist of dry ice.
Cool.
Usually we slow things down, but in this case we're speeding things up. Note the ice cube on the left melts into a puddle of water. The dry ice on the right evaporates into thin air. But what if that dry ice had no place to go? Say, if it was trapped inside a bottle.
The dry ice is just solid carbon dioxide. It freezes at about 107 degrees below 0 Fahrenheit. Now that water is at room temperature. That's almost 200 degrees difference from the dry ice. So it melts really quickly, but carbon dioxide skips the liquid and goes directly to a gas. And because it skips liquid, it can have extremely explosive results.
Now I know what you're thinking. Why is Jeff cutting up pieces of dry ice on a bandsaw? 3 reasons. 1, preparing for an illuminating scientific demonstration. 2nd, dry ice can and will burn your fingers. And 3rd, an extra lean cut of dry ice is easier to cram inside a bottle.
As soon as this converts to gas, it wants to take up about 1,000 times the volume that it currently is. And so we're going to fill about half of this, but it's going to want to be 500 times the size of one of these bottles. You can guess what's going to happen then.
Yeah, I think we're going to have one of our patented kabooms.
Well, we like kabooms, right? So it will probably go kaboom.
Matt and his high-speed cameras are now set up to capture every millisecond of explosive force from the bottle as the carbon dioxide gas expands.
We've got eye protection already. I think we're good to go. I'm just going to add some hot water to accelerate the reaction.
I'm going to accelerate my exit. So when you cover this, we leave.
Ignition.
Ready?
Yep.
Fire hole.
Countdown.
Goodbye.
Yep. No, it's going to happen.
Did we mention this could just be a theory?
No! No! All right, well, I hope you got that.
Well, the triggers were set. We should have it. I just have to restart my art first.
After an on-set defib, we played back our footage at 5,000 frames per second.
Wow. Even that is so fast. That's less than 1,000th of a second.
It literally propelled right at where we were.
Yeah, that whole thing took less than 100th of a second for it to move several feet. That thing is going amazingly fast.
Now we're showing you this a few times so you know what it looks like, so you never, ever feel like trying it yourself. Dry ice or not, this is a real explosion, and not something anyone should mess with. Just how destructive this can be is demonstrated by our next experiment.
We're going to do 3 bottles now. We're going to take it up about 5 notches right now. We're going to put 3 bottles in the water. They're going to be surrounded by a ton of pressure.
So essentially, we're making a dry ice depth charge here.
I would say that's exactly what we're doing.
Pop it in.
Pull that guy down.
All right, I'm out of here. Come on.
Much higher. That's good.
And what's going to happen?
Well, what's going to happen, obviously, they would naturally explode at different times, right? However, those are so close together that once one of them creates that pressure wave, it's going to definitely cascade to all 3. There's no bubbles escaping. So this thing is building up pressure. This could be bad. Yeah, let's give a...
I command you.
Oh.
It's starting to expand.
Oh, my God.
Okay.
Okay,
Get the cameras.
Okay. Cameras are okay. We're good.
Real smart guys. Only 1 bottle burst, and the other 2 are sitting in the middle of our extremely expensive equipment.
Wait a second. Has that gone?
No, I don't know.
Those guys are keep the set
I don't
clear?
think those have gone yet. So keep some distance. Let's set those off manually. There's the other one is live as well.
There, guys. Here.
What? I want to do it. If anyone has any problem with this, speak up now.
Stay back, stay back.
See why nobody should try this at home?
And that tank is 1/8-inch thick steel. There's no way you can bend that with your hands, and that thing looks like tinfoil.
Thrown around like a rag doll. And essentially, that's one bottle.
It's totally unexpected. I really thought that the first one would definitely trigger the ripping of the other two.
I can't imagine what that would have looked like if all three went at once.
Viewed at 10,000 frames per second, one bottle bomb was plenty, thank you.
That is an amazing shockwave. And you can see it starts out pretty asymmetric. It has to move the mass of this thing out of the way. But then it's pretty much a sphere. It's going out as fast as it can. That carbon dioxide wants to expand to something probably the size of a swimming pool.
This demonstrates the law of intended and unintended consequences. Ordinary items, when put together in the wrong way, can become devastating.
This thing is destroyed, man. That is 20 feet away from the tank.
This was here